Alright, so this is LUG question number 1, LUG universal gravitation question number 1, and this is going to be the numeric solution. So like how you would solve it if you wanted to plug numbers in, like every chance you get, and like keep it from being tons of letters, which is totally an option that is A-okay. So here, we've already gotten to this point, we've talked about y in previous videos, so check that out if you're not sure. So the centripetal force equals the gravitational force, and this is going to be useful because the centripetal force gets us to the v equals 2 pi r over t, and t is our unknown, it's the period. So this is going to be useful. If you know this, things will be a little bit easier. So a good place to start here, if you're working with numbers, is by saying that the centripetal force, I'm just going to leave, okay, because I'm trying to get to the centripetal force, and then the speed, and then the acceleration, and then the speed, and then the period. So I'm going to leave the centripetal force, but I'm going to get a number for the right side of the equation. Centripetal force, gravitational force is G times the mass of the one object, which in this case is the Earth, times the mass of the second object, which in this case is the Moon, divided by the distance between their centers of mass, which is the distance between Earth and the Moon, squared. So I'm going to start by finding a number here. So I'll do 6.67 times 10 to the negative 11th times the mass of the Earth, which is 5.98 times 10 to the 24th, times the mass of the Moon, which is 7.36 times 10 to the 22nd, and then I'll divide that by the distance between them squared, so 3.82 e to the 8th squared, and your calculator should be spitting out an answer that looks something like 2.01 times 10 to the 20th. It's a force, so its units are newtons. So that's something, okay? So we have this expression for the centripetal force now. So from here, it would help to say that centripetal force equals mass times centripetal acceleration. So the mass times the centripetal acceleration equals 2.01 times 10 to the 20th newtons. And so now it's kind of a question as to which mass we're talking about, because we have the mass of the Earth and we have the mass of the Moon. So which? Well, it's the thing that's traveling in a circle. So in this case, it's the Moon. The Moon is traveling in a circular path. The centripetal force acts on the Moon. So this is the mass of the Moon. Mass of the Moon we know. So to find the centripetal acceleration, you know, just divide both sides by the mass of the Moon. And when you do that, using your calculated numbers rather than retyping stuff into the calculator, because who wants to retype stuff into the calculator, that divided by 7.36 times 10 to the 22nd gets us to a really, really small number, which is 0.00273333 blah, blah, blah. It's an acceleration. So its units are meters per second squared. I'm going to grab that and slide it on over to the next piece of paper where we're starting fresh. So this is our centripetal acceleration. Whoa, come on, move as one, move as one. So this is our centripetal acceleration, and centripetal acceleration is defined as the velocity squared divided by the radius. So hey, if we find this, I'm sorry, that's not velocity, that's speed. So hey, if we find the speed, we know speed is 2 pi r over t. So if we know speed, hopefully we can find t, and it ain't no thing. So here, we're going to say that v squared equals the radius times that really, really small acceleration, which is that. So you'll take that really, really small acceleration, you'll multiply it by the radius, I'm sorry, not the radius, the distance between the two centers of mass, and you'll find that that is that. Oh, great. Okay, so now v squared equals 1044152 or so. It's a speed squared, so if you're thinking about the units, they would be meters squared divided by seconds squared, but like, I don't know, that's kind of losing its meaning at this point, I think. So I wouldn't worry too much about the units, just trust that you're doing things correct and make them right at the end. So we're looking for speed by itself, which means take the square root of both sides. So you should find that the speed is 1021.8 or so. It's a speed, so its units are meters per second. So this is good and helpful, and we're going to keep it and start on the next piece of paper. So now you should use the idea that speed is defined, the speed of an object in traveling in a circular path is 2 pi r divided by the period. So now you hopefully would notice that your unknown is in the denominator. Always a good idea, I think, and like I've been saying this all year, always a good idea to move your unknown to the other side when that occurs. So it really becomes 2 pi r equals TV. Ha! TV. We're looking for t, so instead, so to get it by itself, what we're going to do is divide both sides by the speed, which we now know, radius, we know, this cancels this, so this is our period. So now it's just a matter of plugging on in. So the period t is equal to 2 pi times the distance between these two centers of masses, which is 3.82 times 10 to the 8th meters, divided by the speed, which we've already calculated is 1021.8 meters per second. And so do that, 2 pi times 3.82 times 10 to the 8th, second answer. So t is, oh gosh, that's long. I'm going to run out of space. So t works out to be 3.103. T is a time. It comes in units of seconds by default. So that's your answer. You check it with the answer given on the paper and notice that it is not even remotely close to the correct answer. So yeah, sorry about that. What you should do to convert it to the answer that I have, I gave it in days because the moon's revolution around the Earth is usually given in days. It's about 4 weeks. In this case, that's actually a little bit less. So you can use that and convert, no problem. This t can simplify, I'm going to rewrite it just to save some space, as 2.35 times 10 to the 6 seconds. Then it's pretty much just dimensional analysis, which you've done tons of times in chemistry. So we have seconds in the denominator. I'm trying to eliminate seconds, so I'll say that for every 3,600 seconds, we have 1 hour, which we do. And then I'll say that I'm trying to get from hours to days, so for every 24 hours, I have 1 day. So in this case, I'll take my given answer, which is that behemoth, and I'll divide it by 3,600. And then I'll divide it again by 24, and I'll see that the period can also be expressed in days as 27.186 days. Oof, lovely. Yeah, so that's that. So that's number 1 from the law of universal gravitation. There are other problems on this worksheet. That might be the hardest, I would say. So that's a good place to start. Review the concepts that I've been talking about, ask me questions on Edmodo and stuff if you still have questions, and shoot, I'll be after school Monday, Wednesday. Thanks.